Ladies and gentlemen, we'd like to thank you for flying with us today, all the way out into deep space. We hope you enjoyed your tour of the stars. It's really, truly a pleasure to be your captain. Enjoy the long trip back. It will take you roughly 2 billion years. All right, well, today we're going to finish up talking about deep space. And sorry for the corny intro. You guys will survive, I suppose. All right, without further ado, let's get to it. Ba-dum-bum, ba-dum-bum. All right. So here we are, Astronomy Deep Space Part 5. We want to talk about how stars change over time. So stars, they go through a life cycle, just like everything, I guess. You know, things start off smaller, they get bigger, then they maybe break down again or something. So stars are going to have a life cycle that we can predict based off of observations of other stars. One of the big things to note here, and we'll talk about it on the next slide too, is notice that so a star forms, great. If it's a bigger star, then it will head in a different path than if it's a slightly smaller star. Maybe this one explains it a little better. So every star is going to begin at this nebula stage over here, where it's like some gas swirling together that's really cool. And then it compresses together because of gravity pulling everything together. And if it's, it'll go to being a main sequence star. Main sequence, meaning like most stars. And then if it's on the bigger side of the main sequence stars, it will go upwards from there and become a supergiant. One day a supernova, kaboom! And then if you're, really cool, maybe you get to be a black hole when you're done. Stars that are in the middle main sequence, so kind of like normal sized stars, as they get older will become red giants and then head towards this white dwarf stage and end with a black dwarf stage. So stars, like I said, they begin as these nebulas or protostars. Lots of gas and dust swirling together, being pulled together by gravity. And then they enter the main sequence phase. Now they're officially a star. This is like a stable period, lots of energy shining really brightly. And our sun is a great example of a main sequence star. Right in the middle, our sun is nice and average. So you'll notice here, it says less massive and massive stars. When we're talking about the size of stars, massive means big, okay? We tend to use this phrase less massive because it's still really big, even though we're saying, saying small star makes it sound like, it's like, oh, it's not so cute, it's like this big. But no, like less massive. So massive is like, whoa, crazy big. Less massive is like normal big, okay? So how do stars change over time? We're just gonna compare these two. So if you're a kind of a medium-sized star like our sun, you'll become a red giant next. Then a white dwarf. So red giant being big, white dwarf being smaller, and then eventually a cooler black dwarf. Massive stars become supergiants, then they explode into supernovas, and then they can become like a neutron star or a black hole, depending on their composition. So if we look at the ESRT on page 15, the star chart, which you should be getting familiar with, the main sequence stars, they're on there. It's like the early stage of a star, like when they're young, they're just little babies. And then we have the giant supergiants, that's like the intermediate stage, like when they're older. And then white dwarf is like nearing the end of a star's life cycle. So here we have it. Kind of cool with the colors here. So the main sequence stars are all of these, and you can see that some main sequence stars are smaller, some are bigger, and some are right in the middle, like our sun. So our sun, for example, will eventually increase in size and become a giant, but it won't become a supergiant. So this star like here, like Spica, will become a supergiant. Sirius will probably become a supergiant. Our sun will just become a giant. And then over time, if you're a giant star, you will eventually go into this late stage, the white dwarf stage, which is cooler temperatures generally and different color. Sorry, warmer temperatures, my apologies. Increased temperature from the giant stage. It's nothing to worry about, everyone. Here's our sun now. So by the time it becomes a red giant, I mean, we're talking like 5.5 billion years. We have some time before the end of the world is coming. Well, at least from the sun. Okay, so what is the fate of our sun? Currently, it's a main sequence star. Right there, you can see it. Main sequence, there's the sun. Then it'll become a giant in the intermediate stage. During the giant phase, it's cooler and larger because it's burning carbon. And then eventually it will become a white dwarf. This is kind of cool. I'm not going to read it to you, but the idea would be like, so on the diagram, if the sun becomes a red giant, like right now, this is where it is. Here's Earth. So where would the sun reach to? It would be basically touching Earth, right? So we would be toast. Not good. Not good for us. So try not to be around in 5 billion years. And then finally, the sun will go towards the white dwarf stage. As a white dwarf, like I misspoke earlier, but it will be hotter and smaller, small and hot, okay? That's the white dwarf stage. And that's it. That's it about the stars for today. So thank you for being here, and we'll have a few questions to answer, but that's pretty much it. So I will see you guys in class. Don't be bad.